Hi guys, for today's lesson we're going to be moving on to reciprocal models. So this is where we're putting reciprocal functions into more worded sort of questions where you have to deal with some sort of model which is going to be using this general reciprocal equation where you've got x on the denominator and you've got some random number up the top and you've got y by itself. Okay, so and remember that when we graph these sorts of equations, they're going to be making a hyperbola shape. So you're going to be getting something that looks like this sort of curve. From last lesson, we were showing that it typically had two branches like that, but in certain contexts, sometimes you only want to deal with the positive branch. The negative branch may not be relevant in certain contexts. Okay, so let's give this first question a try. So the time taken, t, so time is a variable, in hours for a road trip at speed s, where s is the second variable, is this function here in terms of t and s. So if we look at this equation, we can see that t is like our y and s is like our x in this situation. So when we're graphing this, so we need to construct a table of values for s and t, you want your s to be your x and your t to be your y. And we're dealing with different speeds here. So our speeds are probably going to go from like say 0 up to 100, which kind of makes sense. So they start here at 10 and they go all the way up to 100. They're typical sort of speeds. And then they show the different times that the trip takes at these different speeds. And you'll notice that because there's 2,000 up the top, these numbers here are always going to be multiplying to give 2,000. So for example, like 10 and 200, they times together to give 2,000. So remember, that's a quick way to do these tables of values. This one here, I'm pretty sure they've just rounded. So that's actually 33.3 repeater, but they're just rounded to the nearest whole. Okay, so now we've got to draw the graph of this. So we're going to use our table of values to graph this. So you can see here that they're graphing the several points that they're getting, and they get that sort of hyperbola looking shape, which is expected. How long did the road trip take at a speed of 70 kilometers per hour? Now you've got two ways of doing this for the 70. You can use the graph. So here's our 70, and you can go across, and then you can estimate using your graph. But that's not the most reliable way of doing it. The most reliable way to figure out for a speed of 70 kilometers is to change your s to 70. So if you do 2,000 divided by 70, you're going to get a perfect answer for your time. And remember, the time is in hours, so you've got to make sure you use those units. So moving on, we have the next question is, why is it impossible to complete the road trip in 10 hours? So the idea is we want the time to be 10 in this situation. So if we look at our graph, so when if we want the time to be 10 hours, we want it to be all the way down here. There's our 10 for time. So remember, this is time. Our 10 is all the way down here. If we go all the way across to our line, we don't actually end up hitting the line. So the graph's not very helpful for this 10 hours. Let's try maybe the formula instead. So here we've got t equals 2,000 over s. We want our t to be 10, so I'm going to rub out the t and make it a 10. And then when we're solving this equation, you want to think to yourself, well, let's multiply by our s. So if I times both sides by s, we get that 10s times 10 is 10s. So I get 10s equals 2,000. And then I divide by my 10 and I get that s is equal to 200. So a speed of 200. The reason that is impossible is because I'm not allowed to go at 200 kilometers per hour. So that's the sort of answer they're looking for. And you can see here, speed required to complete the trip is 200 kilometers per hour, which is above the speed limit on Australian roads. So that's why it's impossible. Okay, so moving on, let's try another one. So relatively similar sort of question. The cost per person of sharing a pizza. So the cost per person varies, depends on the number of people eating the pizza, which makes sense. So we've got cost as a variable and the number of people eating the pizza as another variable. So this is our equation that we can use to model this situation. Describe the possible values of n. So n is the number of people eating the pizza. So you got to think to yourself, what sort of values of n in our table of values are we going to use? Well, typically we're dealing with people eating pizza, so you may only go up by one person each time. So their answer is n is a positive whole number. It can't be negative amount of people, and it's likely to be less than 10. So that's the sort of values you're going to use for your table of values. Next up, we'll get rid of these. Construct a table of values for these. So n is like your x and your c is like your y. And as we put these values into our function, we get these bottom numbers. Notice that these numbers here will always be multiplying to give your 24. So another quick way to do it. For 5, etc., it's a little bit trickier. You may have to just use this formula straight up. Okay, draw the graph. So you use your table of values to draw this graph, similar looking graph. What is the cost per person if 6 people, so n is 6, are sharing the pizza? So 6 people, that means a cost of $4 each. So nice and simple. You can use the graph or the table of values. You could have also put n as a 6, and you would get that whole cost would be equal to 4, because 24 divided by 6 is equal to 4. And how many people shared a pizza if the cost was $2.40 per person? So our cost, our C along here, is going to be $2.40. That's very hard to see where $2.40 is. It's below $4. So you don't want to be using the graph for $2.40. So use the function instead. Use this equation. So our C changes to $2.40. So when we do that, we get this sort of thing happening here. So our C is $2.40 or 2.4, and the 24 on the N stay put. And we want to multiply both sides by N, and then divide by our 2.4, and then you get this, which equals 10. So therefore our N equals 10. So therefore there was 10 people sharing the pizza when everyone paid $2.40 each. So it's pretty much just using these formulas and figuring out how we can use these formulas to answer some of these wordy sort of questions. Good luck with the questions. Bye.